Hello, good morning to all of you. I am Priyanka Sharma, Assistant Professor AKGEC, and I am going to present my video lecture on Fundamental of Electronics Engineering, that is BC 101. So, in this subject, I am going to cover the complex topic on unit number 5, that is Fundamentals of Communication Engineering. So, in this, I am going to cover up the content, the elements of communication system, and need of modulation. So, first of all, start with the communication system. Let us know first of all about what is communication system. Communication is the process of establishing connection or link between the 2 points for information transfer. So, as we all know that in this today's world of scenario, the communication is very much established among all the areas, locations and over worldwide. So, for that purpose, we have to know about the basics which is behind the communication. And we also know about what are the infrastructure, what are the equipments which is behind this communication system. So, next we are going to study about the electronics equipment which are used for the communication purpose and what are the communication equipments which can be used for the different communication system. So, these equipments when assembled together called as communication system. So, if we take the example of communication system, such as I am taking the example of line telephony we are using earlier days. So, in line telephony we can able to communicate with one another sitting at one end to the other end. We have line telegraphy, we have radio telephony, then we have radio telegraphy. We have broadcasting. In broadcasting, we all know we can able to see any type of situations or any videos which is broadcasting at other end. Then point-to-point communication, mobile communication, computer communication. Computers are connected. That's why we are able to do the video conferencing. Now, we have radar communication. In radar communication, we all know this is essential for the detection of aeroplanes which is landing at the airports. We have television broadcasting. So, any live telecasting we can see with the help of television broadcasting. Radio telemetry, radio aids to navigation, radio aids to aircraft landing. In all these areas, we require the communication system. So, for this purpose, we need to know about the basics of communication system. So, first of all, if we very basic, we will try to find out what are the sources, what are the equipments required. We can see it in the form of block diagram. So, it comprises of different elements. This shows the block diagram of general communication system in which different functional elements are represented by the blocks. First block, here we can see here the source of communication, source of information. So, let's say I am speaking here. So, I am a source of information here. So, I am speaking, or we can say I am giving the audio signal. So, my information is in the form of audio. So, information source can be in the form of sound, it is a picture, it is speech, it is data, it is video, anything is a source of information. And after that, we have an input transducer. Input transducer basically converts one form of energy into other form. So, it converts my audio signal into the electrical signal, because the equipments we use, it is going to be work on the electrical signals. That's why there is a requirement to convert the information in the electrical form. After this, it is given to the transmitter. Transmitter will going to modulate the signal, because my signal is only audible to a very limited range. So, if I want to transmit my signal to a very larger distance, I require to modulate it. So, transmitter basically do the modulation. We will going to discuss this in a brief way in the next slides. After this, it will be given to the channel. Channel is any medium, either it is wireless and wired. And there may be the chances, because we are transmitting our signal to a very larger distance. So, there may be the chances there will be some noise and some other frequency that is getting added up with our original signal. So after this, we will get it at the receiver end. Then at the receiver end, we're going to receive the signal, and it performs the just opposite operation of transmitter. So what we did at the transmitter end, just opposite, that is the demodulation, we can going to do at the receiver end. After this, we get the original signal. It is in the electrical form. So to retrieve the electrical signal back to the audio signal, we again going to put one output transducer here. So this output transducer again converts back our electrical signal into the original, which is in the original form. Either it is audio, either it is video, or it is in the form of text. So these signals that can be received at the receiver end. So we had seen here the basic or essential components of the communication system, that is information source, input transducer, transmitter, channel, receiver, and destination. So let us going to discuss this one by one. So if we first concentrate on information source, a communication system serves to communicate message or information. It originates from the information. This information, I had already told you, it is in the form of audio, words, text, symbols, video, any type of signal. So these signals can be any desired message which need to be communicated. After this, we going to discuss about input transducer. As I told you, this function is required to convert our signal into the electrical signal, because this is the requirement of any equipment, electronics equipment, which is going to process only the electrical signal. That's why a transducer is used, and this is a device which converts one form of energy into the another form. So the message from the information source, which is either in the form of audio, video, text, it can be converted to the electrical signal. So this electrical signal is a time varying signal which is need to be transmitted through the transmitter end. Now next is the transmitter. The basic function of transmitter is to process the electrical signal from different aspects. For example, in radio broadcasting, the electrical signals which is obtained from the sound signal is first processed to restrict its range to the audio frequency, and it is after this it is amplified. So it can be basically processed at the transmitter end by doing the modulation. If we take the example of wire telephony, there is no real processing needed. In long range distance communication, signal amplification is necessary before modulation. So all these things like amplification, modulation, this process can be carried out with the help of transmitter. So if we talk about the modulation, modulation is the main function of the transmitter, which basically converts the low frequency signal into higher frequency signal, or we can say it can superimpose the message signal upon the higher frequency carrier signal. So this is the main function of the transmitter. Now next is the channel. As we had already discussed about, channel is the means of communication through which message transfers from transmitter to the receiver end. There can be many types of channel: point to point channel and broadcast channel. Point to point channel examples are wire lines, microwave lines, and optical fibers. Broadcast channels are those channels which provides the capability to receive the signals at various receiving stations, that is to be simultaneously transmitted from the transmitter end. For example, the broadcast channel is a satellite in geostationary orbit which covers about 1/3 of the Earth's surface. So during the process of transmission and reception, signal gets distorted, and due to the noise effect from the different signals which is passing through the nearby the channel. So what is noise? Noise is basically the unwanted signal which tends to interfere with the original signal, and it is random in behavior, and its amplitude is also different from the original signal, and its frequency is also different. So basically it's going to interfere nearby the channel. Now next is the receiver. Receiver's main function is to reproduce the message signal which is in the electrical form from the distorted received signal. This basically reproduces the original signal. This basically reproduces the original signal which is accomplished by the process of demodulation or detection. Demodulation is basically the reverse process of modulation. That means it separates out the low frequency signal from the high frequency carrier. This is the main function of the receiver. Now last is the destination. Destination is the final stage which is used to convert the electrical message signal into original form. As we had transmitted the signal either in the audio, video, text, words, codes. So this signal we want to receive. So we want to first convert the electrical signal which is received from the channel into the original form. For example, in the radio broadcasting, if the destination is loudspeaker which is working as a output transducer, and this converts the electrical signal into the original sound signal. So this describes the main functions of the communication equipments which is required for the communication system. So now next we are going to discuss about modulation. So this is the main function which is required for the communication to achieve. The remaining parts which we had studied is the part of the communication system, but basically our signal will start from this modulation process. So we need to first know about what is modulation. Modulation is the process of changing the parameters or characteristics like amplitude, frequency and phase of any carrier signal in accordance with the instantaneous value of the modulating signal. Modulating signal is basically our information signal. This is the information signal which we have. So here we can have three types of signals in the modulation process. Basically we are going to see here we have a message signal or modulating signal. This signal contains all the information which need to be transmitted. This is called as message signal. And also it is called as baseband signal which is undergone the process of modulation and it is transmitted by the transmitter end. Now next is carrier signal. It is basically the high frequency signal which has a certain, it is basically the high frequency signal. It has a certain voltage, amplitude, it has certain phase, it has certain frequency which contains no information. After this, on combining these two signals, we will get another type of signal called as modulated signal. We call this as modulated signal. The resultant signal after the process of modulation is called modulated signal, and this signal is the combination of message signal and carrier signal. The next question comes up here, why we are doing the modulation? As I am talking about I am going to talk, so I am transmitting the audio frequency. So this audio frequency signal has a certain limited range. So this limited range can be increased with the help of modulation, and many more requirements which is required for the transmission of the signal. So there is requirement to know about what is the need of modulation. So basically there are the basic needs of modulation. First, we can have a reduced height of antenna. Next is we can avoid the mixing of signal with the help of modulation. Next, third point which we had already discussed, we can increase the range of communication. Next, we can have a multiplexing possible with the help of modulation. We can also improve the quality of reception. We will going to talk about this one by one. First, I am going to take the reduction of antenna with the help of modulation. If we talk about the transmission of radio signal, we can talk about this transmission at this antenna height. The antenna height we will going to take, it is order of the wavelength, that is lambda by 4. So this lambda by 4 is the height of antenna we will going to take for the transmission purpose. And if we are going to calculate with the help of this formula C by F, we can have a minimum height of antenna which is required to transmit audio signal or low frequency signal is given by this formula. So if I am going to take this low frequency range, I am going to have an antenna height of 7.5 kilometers, which is practically unreachable to be implemented. So this cannot be implemented practically or impossible to install it. So if I am going to modulate the signal at a higher frequency range of megahertz range, and in that case I am going to calculate the minimum height of antenna. So this height can be obtained as around 75 meters, which can be practically possible to implement. So with the help of modulation, we had seen here, with the help of modulation at the high frequency range, the antenna height which is requirement of the transmitter end is practically possible. Now next is we can avoid the mixing of signal with the help of modulation. We have a baseband sound signal which is transmitted without modulation, and if we want to transmit with the help of transmitter, if more than one signal transmits which is in the range of 0 to 20 kilohertz, so this will going to mixed up together. So receiver cannot able to separate these two signals. So if we want to transmit it, we have to modulate it at different carrier frequency. So if we want to modulate this, we have a baseband signal which is in the range of 0 to 20 kilohertz. We have a different frequency ranges. If we transmit it as it is, it will going to interfere with each other, and we are not going to differentiate this. But if we going to modulate it at different carrier frequency, FC1, I am modulating this at FC2, this is modulated at FC3. So this can be easily differentiable and this can be easily separable. So we had avoided the mixing of signal, signals. So with the help of modulation, we had seen here, we can avoid the mixing of signal. Next is, we can increase the range of communication. We already know that if the low frequencies travel through a longer distance, it gets heavily attenuated. So to avoid the attenuation, we have to increase the frequency. So in modulation process, we had seen we modulate or we superimpose our low frequency signal with the high frequency signal. So if the frequency increases, so attenuation will become decreased. So if attenuation decreases, we can increase the range of communication or we can transmit our signal to a very, very larger distance. Next is multiplexing. With the help of modulation, multiplexing can be easily done. Basically, multiplexing is the process in which two or more signals can be transmitted over the same communication channel simultaneously. So this is possible only with the help of modulation. Basically, multiplexing allows the same channel to be used by many signals. There may be the example of TV channel that can use the same frequency range without getting mixed up with each other, or different frequency signals can be transmitted at the same time. So this only can be possible with the help of modulation, because in modulation we can transmit different channels. We can transmit different channels at different carrier frequencies, FC1, FC2, and we can receive at the receiver end any channel which is propagated through the common channel. So multiplexing can also be possible with the help of modulation. Next is, it improves the quality of reception. This can be very well seen in case of frequency modulation and digital communication techniques, such as we have pulse code modulation. The effect of noise is reduced to a very larger extent. So if the effect of noise is reduced, we can say the quality of reception will be improved. So in case of frequency modulation, this can be easily improved with the help of pulse code modulation. Now the next topic we're going to see is the types of modulation. We had seen what is the modulation, and we also had studied about what is the requirement of modulation. Next, we can also categorize the modulation in different forms on the basis of signal or on the basis of carrier used. So if we have basically two types of signals, one is analog signal and other is digital signal. So on the basis of that, we can classify the modulation as continuous wave modulation and pulse modulation. Continuous wave modulation is in this case, we will going to take the carrier which is continuous in nature, that is continuous with respect to time, or basically we can say it is analog in nature. The next is pulse modulation. Pulse modulation, we can have different type of carriers. Again, in pulse modulation, we have two types of carriers. One is analog and other is digital. On the basis of that, you can again classify in two types, analog modulation and digital modulation. But in case of pulse modulation, we have message digital or in the form of pulses. So carrier can be changed, either it can be analog or it can be digital. So if we first talk about the continuous wave modulation, it is again of two types. On the basis of that, we have continuous signal. Let us say, take the example of sine wave. This is sine omega t. We have this input signal, and this input signal has three parameters. One is amplitude, one is frequency, and one is phase. Or we can say this signal can be written as A sine omega t plus phi. So this equation, if we see here, this comprises of three parts: amplitude and angle. This is angle part and this is amplitude part. So on the basis of these two types, we have two types of modulation: amplitude modulation and angle modulation. And again, we categorize this angle modulation as, because angle comprises of two parts, frequency and phase. So we have again two types of modulation: frequency modulation and phase modulation. Again, coming back to pulse modulation, as I told you, on the basis of carrier signal, we have two types of carriers, analog and digital. So on the basis of analog and digital carrier, we have two types of modulation, analog and digital modulation. This analog modulation again comprises of three types: pulse amplitude modulation, pulse width modulation, pulse position modulation. On the basis of which parameter of pulse message we are going to change. We can change the amplitude of message, we can change the width of message, we can change the position of message, pulse. And in case of digital modulation, both the message and carrier in the form of pulses. Message and carrier in the form of pulses. So because of this, message and carrier both are in the form of pulses. That's why this can be categorized as pulse code modulation. And we also have delta modulation. So in this, we're going to discuss about, in this subject or in this unit, we're going to discuss about basically the continuous wave modulation. So this continuous wave modulation is basically deals with the analog signal, and in analog signal we have message signal and carrier signal. So message signal is a low frequency signal and carrier signal is a high frequency signal. So high frequency signal is a sine wave. If we take the high frequency signal as a sine wave and it is taken as a carrier, and if further we divide it into two parts, that is amplitude and angle part. So on the basis of this, we again have two type of modulation, amplitude and angle modulation. So if we talk about amplitude modulation, amplitude of the high frequency signal basically changes. So if I am taking the example of this signal as a sine wave, this is a sine wave, and in this I have amplitude of this signal, this is the amplitude part, and this is the frequency omega t, and we have a phase part also, and its equation can be written as St is equals to A sine omega t plus 5. So this I am taking as message signal. This is my message signal. This is my message signal. So in this signal we have amplitude, frequency and phase. This is a low frequency message signal. Now if I am going to take the carrier signal, which is a high frequency signal, this is high frequency carrier signal. So this also can be taken as a, either it is a sinusoidal input or it can be taken as a cosine wave input. So again this has certain amplitude. If I am going to categorize this, I can take it as AM. I am going to take this as AC. This is the carrier amplitude and it has certain frequency omega t. Let's say in linear frequency it is called as FC and message frequency is called as FM. And again if we write this as a carrier signal, this can be written as CT. This can be categorized as, this is AM, this is omega m, this can be written as AC, this can be written as sinusoidal wave omega CT plus phi. So these are the two signals we have in the modulation process. So this is a low frequency signal, message signal, and this is a high frequency signal. This low frequency message signal is called as modulating signal. This is called as modulating signal, and this is basically called as carrier signal. This modulating signal is also called as baseband signal. Baseband signal, and it has a certain frequency range, which is for audio signal, it ranges between 0 to 20 kilohertz. And basically the carrier frequency signal, if I am taking as radio signal, it is in the range of megahertz. It is in the range of megahertz. So continuous wave modulation basically deals with these two types of signal. So we had studied about this, and if we are going to define this in two types categorized as amplitude and angle modulation, we have here three parameters: amplitude parameter, frequency parameter and phase parameter. So this comprises the angle part. So this is called as angle modulation and this is called the amplitude part. So basically in this topic we are going to discuss in detail about the amplitude modulation. So if we are going to define the amplitude modulation, or we can define the amplitude modulation technique, if amplitude of the high frequency signal need to be modulated or is varied in accordance with the instantaneous amplitude of the modulating signal, then such a technique is called amplitude modulation. Okay, so this is called as amplitude modulation. Now, if we want to modulate the angle part, then in this case, if angle of the carrier wave is varied in accordance with the modulating signal, then such type of technique is called angle modulation. And further, this angle modulation is divided into two types of modulation: frequency modulation and phase modulation. Again, we can define the frequency modulation is the modulation technique in which frequency of the carrier, in this case, this is the carrier, its frequency is FC. This frequency is modulated according to the, in this case, frequency is modulated according to the message signal. That means if message amplitude is high, frequency will be higher, or if message amplitude is low, frequency will be lower. So according to that, frequency modulation will take place. And we have another modulation also, that is the phase modulation. Phase modulation is the process in which, again, this signal has certain phase, this carrier has certain phase phi. This phase can be modulated according to the phase of the signal is modulated according to the message signal. So if phase is low, 0, if amplitude is low, the minimum phase will be there. If amplitude will be higher, maximum, we can say it has a phase shift of 180 degree, or if in between the two signal amplitude will be there, there will be the phase shift of 90 degree also, according to the what we had taken. So these are the different type of modulation technique which comes under continuous wave modulation. So in the next video lecture, we are going to discuss in detail about the amplitude modulation technique and its equations and its fundamentals and how we are going to derive that. So thank you for this lecture. Jai Hind.